Good afternoon and welcome to the webinar on the future of software engineering and acquisition with generative AI. My name is Anita Carlton. I will be serving as the panel moderator. In terms of my background, I lead the software engineering portfolio of work called the Software Solutions Division at the Carnegie Mellon University Software Engineering Institute. And I have more than 35 years of technical and senior leadership experience in the software engineering industry. I wanted to start by making a connection of what we'll be talking about today with a recent national study we led engaging the global software engineering community to think about the future of software engineering. It was titled Architecting the Future of Software Engineering, a National Agenda for Software Engineering Research and Development. In it, we defined a vision for how software-intensive systems of the future would be developed. And of course, AI plays a prominent role. Our vision included humans leveraging trusted AI as a workforce multiplier for all aspects of software creation, with humans and AI working as trustworthy partners and collaborators to rapidly develop and evolve systems based on programmer intent. While some of these ideas seem more obvious today, these ideas weren't common practice in 2019 and 2020 when we were working on the study. So AI-driven approaches are changing the landscape of everything that we do, bringing automation to every part of the software development and software acquisition process. And there's a lot of interest in this topic, judging by the great response that we've had to this webcast. We've received 60 to 70 questions, so we'll work hard to try to address as many questions as we can, but we've got a lot of material to cover in the next 90 minutes. So we have a great lineup of experts to help explore the future of software engineering and acquisition using generative AI technologies. We'll discuss a number of topics today, from opportunities for using generative AI techniques in software development and acquisition, to discussing some gaps and risks of using generative AI, outlining the critical skill sets required by software engineers and stakeholders to harness generative AI's potential effectively and responsibly. And then we'll conclude with talking about how we see the future in this technology space. So we have a great panel of experts to weigh in this discussion. We'll start with Dr. Doug Schmidt. Doug wears a number of different hats at Vanderbilt University. He is the Cornelius Vanderbilt Professor of Engineering, the Associate Provost of Research, Development and Technologies, the co-director of the Data Science Institute, and a senior researcher at the Institute for Software Integrated Systems. He's also a visiting scientist with us here at the Software Engineering Institute. Doug is an internationally renowned and widely cited researcher whose work focuses on pattern-oriented middleware, Java concurrency and parallelism, and generative AI. Next, we have John Robert. He's a principal engineer at the SEI and the deputy director for SEI's Software Solutions Division. He provides leadership for software engineering research and development, works very closely with the Department of Defense and industry to enable the broad transition of new software engineering approaches. John's primary research interests include applying generative AI to software acquisition, AI-augmented software development, and devising continuous assurance practices for software engineering. Next, we have Dr. Ipek Oskaya. She's a principal researcher and the technical director of the Engineering Intelligent Software Systems Group at the SEI. Her research areas include software architecture, software design automation, and managing technical debt in software-reliant and AI-enabled systems. At the SEI, she's worked with several government and industry organizations in various domains, including avionics, power and automation, the Internet of Things, healthcare, and IT. She's the co-author of the recent managing technical debt, reducing friction in software book, and she's just finished a 5-year tenure as editor-in-chief of the IEEE Software Journal. Next, our colleague James Ivers. He's a principal engineer and leads the architecture, design, analysis, and automation group at the SEI. His experience spans research and application of work in software architecture, code analysis, formal methods, and scaling our ability to evolve software. His most recent work focuses on using AI for software engineering to support large-scale refactoring. And finally, our colleague Shen Zhang. He's a senior software engineer within the Enabling Mission Capability at Scale Directorate at the SEI. He provides expertise in software development processes and static code analysis for real-time mission-critical software systems and with Air Force and Navy programs. More recently, he's been involved with using large language models to accelerate software engineering use cases. Prior to working at the SEI, he developed simulation products for industrial control systems in the commercial power industry. So with those brief introductions, let's get this discussion started. So the first question that I have is, what do we mean by generative AI? And what are some examples of organizations using generative AI techniques? Doug, it would be great if you could get the discussion started here.
Great, thank you very much, Anita. Welcome, everybody. I'll just talk about a couple things today to introduce the topic, and my colleagues will go into much more detail. So generative AI is a class or a subset of overall artificial intelligence that makes it possible to generate new content. It can be different kind of content. It can be text, often text. It could be images, if you've played around with things like DALL-E or Midjourney. It could be music. It could be code. We'll talk a lot about code today. And these generations come from training on large data sets, vast data sets, looking for patterns and different ways of finding identified structure in those data sets. There's lots of different kinds of AI. Right now, generative AI is kind of sucking the air out of the room, but there's many other kinds of AI. And classically, AI was often involved in interpreting or classifying data. And one of the things that characterizes generative AI is its ability to create new data, new content, new images, new music, et cetera, that don't necessarily directly replicate the input that they were trained on, but it learns from it, it uses the patterns and the structure from that content. One of the other things that differentiates generative AI is how easy it is to use it. For the price of a couple of cups of Starbucks coffee a month, you can get subscriptions to various providers of generative AI, OpenAI's ChatGPT, Anthropic's Claude. There's similar things coming out from Google and others. And you can use these tools without having to go and get expensive licenses or download software to your system. You just need a browser and an imagination and some time to play around with it. We're going to talk about a lot of different ways that generative AI can be applied to software acquisition. And here's just a quick summary. So we're going to talk about using generative AI to generate code. That's what a lot of people like myself do when we think about programming. I teach a lot of courses that use this for the courses I teach. You can also generate other things besides code. You can generate configurations and deployments, stuff you need to make the code work. Something that's become very near and dear to my heart over the years is support for testing, being able to generate test cases, being able to provide simulations that are high fidelity and very creative ways of combining different means to push the code to make sure it works properly, or test systems with various types of penetration testing or fuzz testing. Something else you're going to hear a lot about today is applying generative AI for discrepancy analysis, looking for differences, inconsistencies, gaps in requirements documents, in various types of system architecture documents, safety and security guidelines, other things that are more of the upstream portion of the software lifecycle. And something else I'll just mention very briefly, and then I'll turn it back to Anita. People can also use these tools for various types of cyber defense, trying to test to see whether systems are vulnerable, being able to figure out ways to overcome vulnerabilities that are identified. So the sky is the limit, and we're very excited to talk about both the benefits and the advantages of using generative AI, as well as the risks we have to take into account when trying to apply it in a DoD or commercial software acquisition environment. So with that, I'll turn it back to Anita.
All right, great. Thanks, Doug. In my opening remarks, I had made reference to a future vision of humans and AI working in tandem. So what does it mean to pair a human with generative AI? James and Ipek, could you please share your thoughts here? And James, if you could get it started.
Sure. Thanks, Anita. So I think one thing that's really important is when we look at things like ChatGPT, as Doug mentioned, a human is typically in the driver's seat, and most of our uses in software engineering are very developer or human in the loop workflows. And that's really important because it's a person who points generative AI at the specific kind of problem that they want to solve, provides assistance to generative AI in terms of structuring the problem into smaller pieces that it can solve. But also, really importantly, sanity checking the results. For example, if you are generating source code, is the source code appropriate for your task? Does it pass your tests? And so really this sets us in the place to step back and look at a broader perspective. It's really easy to think about generative AI as just generating that source code. But as software engineers, we have a wider responsibility, and a workflow for generating a new capability or a new feature starts with understanding the requirements, designing a solution, integrating it with an existing system, generating the code, generating tests, and so on and so forth. And generative AI can be helpful in many of these tasks, and maybe more so in some than in others. So it's helpful really to think about that workflow as a whole, because that helps us think about the right combination of tools and techniques. I want to use generative AI to generate the code, but I want to use my traditional unit test infrastructure to check the results or run it through a vulnerability scanner. And I think a lot of the power comes in not just generative AI itself, but generative AI coupled with other practices, including that human intelligence to guide it to the right things. And that pairs up with one other important perspective, which is how do we judge the success of these kinds of workflows?
Yeah.
And for that, I think it's helpful to step back and take that broader perspective. If your workflow starts with a feature request and ends with a merge of that feature into a code base, there's a lot of activities. Generative AI will speed up a number of them, but it might slow down others. For example, generating code might be a lot faster, but you might spend a little bit more time in test to deal with mistakes. That's okay, and we need to embrace that as a new way of working because it's an opportunity. And so long as the whole workflow is better, we've got wins that we can exploit, and I'm sure we'll explore more of those today.
Great. Thank you so much, James. How about you, Ipek? Your thoughts, please.
Thanks a lot, Anita. I mean, this is, of course, an area that is near and dear to all of our hearts because it really comes into understanding what are the kinds of tasks that we're doing that rely on humans versus rely on different kinds of tools that are available to us. The way I think about the problem is maybe in two areas. One is who do we trust for what kinds of tasks? And the other is who does what? And I think that's where we're looking into maybe slight shifts in some of the activities that are involved in the software engineering lifecycle. And while these shifts are happening, what are some of the other tools that enter the workflow of the software engineering tasks? I think James said it well in terms of we will never lose the reliance on humans. Humans will always be on the loop, and there are all kinds of variations, humans on the loop, humans in the loop, and that partnership will be now much more critical in terms of exploring how generative AI adds to it. I think the opportunity here in terms of the human and generative AI partnership is, are some of the tasks shifting? And while those tasks are shifting, what are some of the new things that enter into the workflow of the overall generative AI and human partnerships? Like, for example, let's take trust. We never trusted humans as well in that partnership, and generative AI is not necessarily going to do better, but maybe there will be a point where we will be able to trust the tools a little bit more than we trusted humans. And that means what are the delta and what kind of tools we need to develop for that delta that help the human AI partnership and really improve our ability to develop correct systems, but also focus our attention on the areas where humans really are better at. And I think those shifts are really where the opportunity is in terms of the generative AI capabilities that we're seeing today. And in fact, there are some research studies that are coming up where they're really doing well in some small tasks, which is an opportunity, but this is not to mean that all of a sudden these tools are going to be able to accomplish all the end-to-end tasks that are available out there.
Great. Well, both of you talked about workflows as we looked at humans interacting with AI. My next question is, what are the opportunities then for generative AI as we think about software engineering and software acquisition? And on this question, I think I'd love to hear from all of you because you all have various perspectives here. So Ipek, maybe I'll start with you, and I'll have Ipek, Shen, James, Doug, and John weigh in.
So one of the areas that I think is very interesting, and we don't know how this is going to shape, is whether the workflows of an end-to-end development effort will shift. And I think we've seen some slight shifts in the past. Like, for example, when we had the test-driven development, rather than testing everything at the end, we started testing it in the beginning of the development effort. That helped us catch problems earlier. That helped save some of the efforts and errors down the line. So we'll probably likely to see similar shifts in terms of the order of operations, the order of tasks that happen. And I think that's where the opportunity is. And also that's where those of us who are more in the where research hats are very excited. How do we understand what does it mean whether a workflow will change? Will the workflows even change? Or are we just looking at improvements in terms of efficiency? And more importantly, what kind of data do we need to collect as we're instrumenting these processes and using these tools so we're able to make decisions, or we're able to assess things with an empirical basis rather than making assumptions just because we want to see things improve in a very fast pace. So I think it's really based on understanding what kinds of steps will change in the workflow and what data is needed to be able to understand that. So that's where I think it becomes important in terms of the order of tasks.
That's great, Ipek. How about you, Shen?
Thank you, Anita. I think one of the key areas here, and Doug sort of harped on this at the beginning, is the use of generative AI for documentation. And documentation goes very much side and side with software engineering at various stages within the software development lifecycle. So looking at design documents, for example, we have traditionally put in a lot of effort in writing design documents, in making sure implementations adhere to that. And for the most part, depending on the nature of the software, depending on the nature and the format of the design document, it can be a very tedious process. Well, with generative AI being able to consume both text and code, it's possible for us to leverage that tool and that technology to ensure conformance to design documents and whatnot. On the other side of the life cycle, when it comes to testing, I think there's a lot of potential in using generative AI to generate test procedures. Test procedures are often a headache for many software engineers to write for their testers downstream. But if we can help build a link, essentially a documentation pipeline that leverages generative AI, I think that would be a tremendous time saver and really allow software engineers to do what they love best, which is typically coding.
Yeah, that's great. Great insights. James.
So I tend to think about these opportunities from a few perspectives. One is, what's a natural problem for generative AI? What's a good fit that generative AI is really good at this? Maybe I as a developer am not so good, or I can benefit from other things. Good examples of this are brainstorming, right? Using generative AI to think of other ideas you might not have thought of and help that exploration space. There are other things that generative AI is good at, which is very repetitive, very common tasks. So think the scaffolding for a web application. Give me the structure to get started in, then I can come in and really marry that to my domain-specific information. I know more about that, but you can get me started. So finding those blends of activities are really, really helpful. And they also kind of play along with the themes of how much do I trust what it's going to give me. And here an interesting idea is a lot of us, as we were coming up in the field, had mentors who gave us advice along the way. There's lots of opportunities right now to ask generative AI, I need to come up with a proposal for my manager. What are the elements I should include in a proposal? Or how should I approach a testing strategy? It's not necessarily going to be organizational program specific, but for those who are coming up and learning, it's almost like having a mentor who gives you pretty good advice. Not that you trust everything, but we don't always trust our mentors either. So it's really, really kind of helpful in that kind of regard. There's some more advanced use cases where I think knowing if the LM is giving you the right idea, for example, code translation, moving from one language to another, there's some subtle issues. And for that, maybe it's really helpful to have a more experienced developer at the helm working with generative AI to check the results. So there's a lot of variation, but I think we look for opportunities, or I look for opportunities where the problem I have is a pretty natural fit. I have a good handle on how to use the results and tell if they're right for me. And that gives me a running start. And there's lots of things like that out there.
Great insights there. Doug.
I'd like to riff off of what both Shen and James were just saying. So I'm going to take a step back. Obviously, these technologies are very good at generating or analyzing documents, but I want to think a little bit more macro level. So when people do large-scale acquisition programs, today they're typically characterized as being very static document-centric processes with dozens or hundreds or thousands of PDF files and Word documents and so on. And it's very easy to quickly lose track of what information is out there. And as a result, people spend an inordinate amount of time trying to reconstitute situational awareness of the documents that they produce for all kinds of different purposes, requirements documents, architecture documents, test plans, you name it. It's just hard to keep track. You're finding needles in a haystack. And so one of the things I think generative AI can be very effective for in that context, to James's point about what it's good at, is being able to enable more dynamic and information-centric processes to deal with all this information, especially in terms of being able to search through a large corpora of data and figure out what's there and then summarize it. So if you think about the way we typically build systems now, we build test plans, requirements, people spend a lot of time writing lots of information over and over again, which very quickly becomes difficult to maintain and be consistent. So if you can imagine a world where you could write specific things down and then use LLMs to glue the pieces together to extract the parts and summarize it in an accurate and efficient manner, it would make it a lot easier to deal with these very large document-centric processes that are inflexible today and make them easier for humans to navigate through and sift through and get the information they need. You can basically think of this as sort of Google search on steroids, where rather than getting back a set of links, you get back pre-digested information that you can use to solve your problems more readily.
Great. John, we haven't had a chance to hear from you. And knowing you, I'm guessing you have some thoughts with respect to generative AI and uses in software acquisition.
Absolutely. Thank you very much, Anita. As you've heard a couple of times already, there's so many different potential opportunities to use generative AI in acquisition. So, for example, request for information, generating a request for information, summarizing documents, as Doug was saying, looking at regulatory compliance. So this is an area of high interest because, as Doug mentioned, there's a lot of regulation in the acquisition process. And trying to track the developers and the activities to ensure compliance takes a lot of time. A lot of information flows through that. So having a standards document and then having the ability to look at different artifacts and compare to that, it really helps accelerate the process. As James said, it's about accelerating the process and being more flexible and accepting the fact that some things may be accelerated, but at the same time, we may have some areas that we need to spend a little bit more time. I'd also like to say that another area of interest is project status. There's an enormous amount of communication about the status. And so just imagine having the ability to look through the last several months of information and summarizing and understanding maybe for a certain area, what has been the status progression over this time period on this one topic. And I also like to say something about the customization. One of the real strengths about generative AI is the ability to customize in an interactive way, as Doug was saying, through prompt engineering. So prompt engineering really enables the users to ask questions, be interactive, and with progressively more expansive or more specific prompts, enabling a better response from the generative AI that may be able to be used faster. So it's a bit different experience entirely and very customizable for the user.
Great. Thank you so much. Well, I wanted to bring in a question that we've received from our audience. It's a question from Stephen, and it relates to these different opportunities for using generative AI. He asks, how will adoption of generative AI change the culture of software developers, product managers, customers, and regulators? And so I think that, goes hand in hand with the questions or the discussion that we were just having. So I wondered if any of you had thoughts about how adopting generative AI would change the culture in various organizations.
Well, I'll take a quick shot at that.
Yeah,
So
please.
one of the things that I think we often do in organizations is we stop taking a careful look at the actual document contents, and we instead, based on what we think the documents mean, we see this a lot with standards and specifications for safety, where they've almost become sort of theological in the sense people don't read them carefully anymore. And I think one of the things that will happen with generative AI is it will take a much more cold, hard, objective look at things and find discrepancies and inconsistencies that people start missing over time because they don't read the document for what it says, they read it for what they think it's going to say. So I think that's part of it. At the same time, I think we're also going to see people being perhaps giving more scrutiny to the results that come out of the generative AI. We should already be wary of anything that we see from the internet because you never quite know what the origin is or the provenance. But I think people need to be engaged. James made this point earlier about the human is always in the loop. So we can't let ourselves fall into complacency where we just take it for granted that it produces things that are going to be correct out of the box. But hopefully we take a measured look and use these tools, perhaps different tools from different LLMs, to cross-correlate and do sanity checks to make sure we're not just taking things at face value.
Great. Thanks so much. Ipek, I think you wanted to make some remarks here.
Yes. So thanks, Anita. One of the things I think we need to keep in mind is generative AI, while it's as exciting it is, it's another tool. And I think some of the adoption mechanisms are no different than when we saw other tools that emerge and we brought into our organizations. With the excitement, I think one of the things that we sometimes lose track of is asking the most fundamental question: what problem are we solving with this tool?
Yes.
And where do we insert it? And how does that particular aspect of generative AI, be it acquisition, software engineering, or any task that you might have at hand, does this tool is really the best one? We'll get to this. And how does it really merge with the existing tools, existing business processes? And I think these are not new questions. We've had these questions and we know ways to solve it. And I think for all of us, we need to be reminded often that some of the things that we already know apply and how we're going to work on it. The other aspect is the trust, as we mentioned. We should not assume that just because we have these tools, things are going to work and everything will improve. How are we, again, bringing back it to what is the problem we're solving? Where is this tool apply? And what are measures are we taking to make sure that this tool is solving our problem? And I think this is common sense and applies to all the know-how we had from other technology adoption problems that we solved in the past.
Yeah, thank you so much. I think measurement is really an important aspect to factor in here. Shen, I think you had some thoughts here as well.
Yes, Anita. I'll chime in and say that, one of the benefits of Gen AI is that it really shortens the time to synthesize a lot of code and text, right? So I think one of the major cultural shifts is this understanding that a lot of, I'll say, paper products, be it in the form of design docs and documentation in general, will most likely be of interest, have it in higher quality, right? And it's not an afterthought, because the better we have that in qualities, in higher levels of quality, the more we can feed that back into Gen AI and really leverage it as part of the product that we deliver to the customer, or whatever product or whatever problem we're solving.
Great. Thank you so much. So we've talked a little bit about the opportunities for using generative AI, but what are some of the gaps, the risks, the challenges that you all see in using generative AI that need to be addressed to make it more effective for software engineering and software acquisition? Shen, I'd love to start with you. Maybe Shen, John, and Ipek, your thoughts, please.
All right, so I think we could probably have a whole webcast over the gaps and risks of Gen AI, but I'll focus on two specifically. One, and I think this is very important in DoD, is explainability. And explainable AI is critical, because the less we make Gen AI a black box and have an understanding of what comes out, the better, especially when we use it for critical mission and safety sensitive applications. And so there's a lot of research in this field, and there's a lot of techniques available today. For example, chain of thought, and even when you engage in ChatGPT, you can have it explain step by step in in how it reached some of its conclusions. But I think there's a lot more to be done in this research area, especially when it's critical to explain where some of that data came from, right? Especially if it's data that's been inferred upon, or if it's data that's extracted from a document, and so forth. The second area, which I think is critical, again, especially for the DoD, is security and disclosure. For a lot of our DoD customers, we're working at impact levels IL5 and beyond. And one cannot just take that information, be it text, code, or any kind of input, and pass it into a commercial LLM service like ChatGPT. So being able to find a middle ground between, for example, local large language models and capabilities on the commercial side is going to be critical in ensuring we have a balance between capability, security, and disclosure of sensitive data.
Great considerations. John, what are some challenges from your perspective that we've got to be aware of?
Absolutely. As Shin mentioned, there's lots of different things we could discuss here. So before I will go into one or two, but I want to mention maybe a couple of resources for people very briefly. There's a white paper called Assessing Opportunities for Large Language Models in Software Engineering and Acquisition, which goes through a lot of conversation about how to balance the opportunities and the risks. And at the same time, there's a recent blog that Doug and I did on 10 benefits and 10 challenges of applying large language models to acquisition. And there's some themes to get into details in various areas, but I'd like to say that one of the key areas is human oversight, that there's a need that the process, whatever tool one is using in acquisition in particular, there has to be human oversight. There's never the intent to replace people with the large language models or generative AI. It's about how do people, as mentioned by James and others earlier, how do they bring it in, this new tool into the process? How do they interact with it, and how do they ensure consistency of that process? I also want to mention there's a concern about maybe overhyped expectations. There are a lot of conversations out there about what generative AI can do. And as we see in a lot of hype cycle, there can be times where it's maybe a little bit too hyped up, but at the same time, there's still a lot of opportunities. So accelerating the activities, 30, 40, 50% maybe is a huge opportunity, but at the same time, we need to go in cautiously that it won't solve every problem.
Yeah, great comments. Ipek, how about some gaps and risks from your perspective?
So I will bring the scale of the systems and evolvability and sustainability aspects. I think we are at a place at this moment of time in the evolution of generative AI-based software engineering and acquisition tools is we don't know what we don't know. And the scope of the development tasks, implementation tasks, and there are lots of opportunities, but they are still more narrow in scope. Maybe we're interacting with multiple methods, multiple classes. However, especially the kinds of systems that we all deal with at the Software Engineering Institute, they are systems that are developed over decades. They're going to be in operation for decades, and their development is really large scope. So how does the overall structure, behavior, software architecture, system architecture of the system, and how we think through those kinds of activities gel with generative AI is a huge unknown. If I'm making changes in one particular area, if I'm generating in one particular area, how does it propagate to other similar areas? Or how does it influence some of the other dependencies? This is a very complicated problem. And there are already approaches in terms of planning techniques and whatnot that are emerging there. But I think, as John said really well, we shouldn't assume that it solves all the problems. It has places, and where are those places? And maybe it should not be applied in larger scale, but there are opportunities and gaps there. And which also goes back to the kind of data that is needed, because we have the code and implementation data that allows us to be able to zoom in on maybe smaller scope mistakes, improve some of the implementation aspects or testing aspects or code summarization. But do we have the data, or are we generating the data that will enable us to use these tools for other kinds of tasks is still a huge gap, I think, that needs to be solved. And it also will show itself as risks, because if we don't have the data and if we don't have the ways to check them, that might propagate through the system in unexpected ways.
Yeah, Ipek, our colleague Nadeem from SEI asked a question along the lines of what you were just talking about, which is, what are some of the key challenges you foresee in curating data for building a trusted large language model for acquisition in the DoD space. And I wonder if any of you have some of your insights from working with the DoD programs here. Shen, I'm just calling on you, Shen, because
Sure.
I saw your head.
So, in the acquisition space, there are a lot of templates and, standard deliverables that are for the customers that are imposed upon vendors as part of the contract. And so there is a lot of burden on the government in terms of assessing, deliverables from contractors to make sure they adhere to those standards and deliverables. So where generative AI can come in and help with that in that field is making sure that it meets those standards, and more importantly, the quality comes in, and we have objective review of the data coming in. And that's one of the key things in acquisition, right? Is that if you're dealing with multiple vendors, for example, in a request for proposal and whatnot, the information coming in from different vendors, it's critical that there's objectivity in assessing some of their proposals. And generative AI can certainly be a help with that. Of course, they'll have their own biases. And I think this circles back to having that human in the loop to help mitigate any risks there.
Thank you. I really appreciate your thoughts. John, I know you've worked a great deal with Navy programs and thought you might have some insights here as well.
Sure. As we look to building models that really help enable software acquisition activities, I think some of the early opportunities we're seeing is in specific areas or domains. So an example, a government standard for safety in a certain domain of system. It could be aircraft, it could be ships, it could be what have you. And that regulatory document, it could be 100, 200 pages, outlines a number of different things that it expects to have happen from the developer, from the acquisition program office, but all these things need to be done to ensure safety and compliance in that domain. Where we're seeing is that the opportunities to develop large language models, or maybe some tuning or refinement of large language models, is on that specific area, because it turns out that those safety standards are usually supported by specific teams in the government who are interacting with multiple programs, have some data sets available to them, have people that are trained. And so this is the kind of thing that can augment or be a resource for that team. And I think that's some of the near-term opportunity, because it's scoped or bounded in terms of the types of data that needs to be available. And it also has government organizations that are already accessing and using some of that data, which, as we know, collecting and getting the data turns out to be, a huge challenge in the Department of Defense for various reasons. So I think specific domains first, and then maybe more broadly after that.
All right. Thanks so much, John. James, did you want to weigh in?
Yeah, so I want to maybe push back just a little bit on the framing of the question. So if I remember correctly, part of the question was a trusted generative capability.
Yes.
And I think one thing that we should remember is not all of our trust has to be on the AI itself. If we think about the workflow, if we trust the outcome because we put other safeguards, human or static analysis or whatever in place, that we don't always have to have exact trust in the AI if they're complementary perspectives. And again, that's stepping back to think about the workflow as a whole. Do we trust the workflow is maybe a better question than do we always trust the AI?
Thank you so much. Apparently gaps, risks, and challenges have everyone excited here, because there's a lot of questions here. So let me hit on another question from the audience. It's from Travis. I have a huge question. I am aspiring to become a software engineer, but with AI being able to generate code much faster than a human, is it still worth it to study software engineering? And so Doug, I've got to start with you on this one. The professor from Vanderbilt, please.
As you can imagine, this is a question I get asked repeatedly now with my students in my classes, and it's on everybody's mind. I'll just point to a couple of interesting things. These types of challenges, the way in which new technologies have impacted and influenced what you should study, what language you should learn, what platforms you should use, what techniques and methods and tools you should apply, has been going on for decades. If you take a look back to the late 1950s, people who were whizzes at assembly language were very worried that Fortran was going to put them out of a job. Each new generation of technology has displaced people who were unable to move away from the old way of doing things and adopt a new way of doing things. The best way I would answer that question is to take a look at something called the Jevons paradox, Jevons, Google Jevons paradox. And basically what it says is, as we get increased efficiency through tools and automation like generative AI and all kinds of other stuff, model-based approaches, frameworks, middleware, language improvements, patterns, you name it, the demand for software engineers is actually going to increase, not decrease, because there will be a growth in demand for new applications, new tools, new smart this, smart that. So we'll actually see a growth in demand for capability. However, that means that you're going to have to adopt and adapt to this new world. You're going to have to learn about things like prompt engineering that John talked about before. You may have to learn how to test and train and fine-tune large language models. You'll certainly, to everybody's point so far, need to learn how to deal with non-deterministic outcomes that don't give you the same results every time you ask the question. Some of those skills are things that we're comfortable with today. Some of them are brand new. People who've done software patterns for a long time will quickly adapt and adopt the prompt engineering patterns. It's the same concept, just applied at a new level of abstraction. So I'm actually quite enthusiastic that if we're willing to take the time to retrain ourselves and keep learning, then we're going to be in great shape, because the world is going to demand these systems work in ways that are survivable and effective and suitable for the task and so on.
Excellent. Great thoughts. James, did you want to also comment?
Well, so I think I very much agree with what Doug said. And I think in the short term, what I expect people to find is those engineers, software engineers in particular, who are leaning forward and learning these techniques and figure out where they make sense and where they don't. They will make a difference in their organizations and they'll stand out. Those who say, oh, it's all overblown, it's all going to go away. You know, some of it is overblown, that's fine. But find solutions, find paths for how you can do things and be the innovator in your organizations. That's always going to set you apart, whether it's generative AI or another new technology.
James, I think that's great. Nancy, one of our colleagues, also offered a comment. Software engineering education will evolve just as it has before, and software engineers in the workforce will learn and adapt as well. Ipek, did you also have a comment?
Yeah, so there's definitely going to be a lot of room for evolution, that's for sure. But I think it's important to also keep reminding ourselves implementation development is only one of the software engineering activities. There are quite a number of activities to make a system work that are probably gets lost because these tools are good in implementation. Maybe they'll get better in testing and so on. But recognizing that engineering, it's an engineering degree, and software is the tool, and there are quite a number of aspects, and there are quite a lot of challenges going forward that does and does not involve AI. So I would not equate software engineering to these tools. There are quite a number of open questions to address, and we definitely need more software engineers to be able to address them.
Yeah, that's great. Really appreciate those thoughts. So I'm going to move forward to some other thoughts and questions here. How would someone make a decision on whether they should use generative AI for software engineering or software acquisition? Because we've talked a little bit about adoption and some uses, but how does someone make a decision on whether they should apply these Gen A techniques or not? Doug and James, I thought you both could take a shot at that. Doug?
Sure, let me take a quick stab at that one. So I think it's, in many ways, it's the same way that we always do technology adoption decisions. We do trade studies. We try to understand what our requirements are. We make sure that the tools that we have at our disposal are suitable and fit for purpose. So that would be a starting point. So for example, going back to the discussion we just had about code generation, the benchmark, the litmus test for generating code or writing code is perfection. If you have an AI tool or if you have a compiler that generates very optimized code, but it only works 95% of the time, probably not going to be acceptable. Same thing is true with today's automatic code generators with AI. It's often very creative and does some cool stuff, but when it's not right, people get nervous. There's lots of other parts of the software acquisition process, to Ipek's point, that don't have much to do with generating code or even generating test cases. There's the upstream activities about requirements definition and making test plans and analyzing consistencies between different documents. Those things don't have perfection as the standard. They have usefulness. And people are often not very good at those kinds of things at scale. So I think that's one thing to consider. What kind of problems are you solving? The other thing that's really important to remember, same way when we think about adopting new languages or platforms or methods and so on, how skilled is your workforce and how willing are they to learn new things? One of the things that concerns me a lot when I talk to some of my very learned colleagues who are very skeptical about AI is they think it's supposed to be perfect out of the box without humans having to be involved and without having to learn new skills. So I'm a big fan of prompt engineering. I'm a big fan of using techniques like retrieval augmented generation to try to reduce the hallucinations. And I think, as we would all agree, we're all big fans of keeping people in the loop to make sure that these things don't go off the rails and they help solve real problems.
Excellent, Doug. How about you, James? Your thoughts?
So first, I'll mention a report that John Robert mentioned earlier. Shen, Ipek, and I all contributed to that report. And what we did was we tried to take a look at different use cases and think about some of the challenges or concerns that might affect adoption or use of LLM for use case. I won't repeat everything that's there. You should go take a look at it. But concerns that, for example, Shen raised earlier about explainability and disclosure of information to a third-party service are things that you think about. But, you know, to play a little bit of, or put that in perspective, those concerns aren't always relevant to what you're trying to do. For example, if you're trying to generate a web app, you can say generate a web app that has tables and checkboxes and whatnot without disclosing any of your proprietary information and still get something useful back. So there's some use cases where, while disclosure is generally a concern, it may not be as applicable. So try and put your use in context and think through it in terms of those criteria. But another thing that was interesting in that report that we looked at is, let's step back and think about this from a risk perspective, right? So I come into use of generative AI with the assumption it's always going to be wrong some percentage of the time. That's okay. How do we compensate for that? And so we thought about, from a typical risk perspective, you think about probability of something being wrong and what's the impact of it being wrong. And I think if you do that with Gen AI and focus just on Gen AI, you're missing opportunities. That's why I keep talking about stepping back to the workflow. Because if you think about the human and the AI together, you can kind of change that picture. You still care about what's the impact of being wrong, but now you have the opportunity to think about what's the chance that a human using Gen AI can spot the mistake and correct it. And so that changes your risk perspective to what's the effect of these two working together versus what are the limitations of the underlying technology that's only part of the solution. So that broader perspective helps. Marrying your concerns to your specific use case and your organization's concerns helps. And there's a simple way to think about that we've shared in this report, and we encourage people to take a look and maybe share some feedback with us.
That's excellent. One of the questions that we've received from the audience is, how do you test AI generated code? Is it through more AI, or is it something else? And he makes another comment. This is from Roy. Hope that other new technology will somehow fill the void. And so I wondered if some of you may have thoughts there about testing AI generated code.
I'll start. How do you test code, right? I mean, so AI generated code is code. How do you test code? Right. So when I use Gen AI, again, I tend to think it's going to make mistakes. So before I use Gen AI, I think about, how am I going to validate the result? It's very much like a test-driven development mindset. I'm writing code. It's supposed to do something. How do I test it? Now, one thing I don't think we've talked maybe a whole lot about is one of the cool uses I found with Gen AI is generating test data. Particularly if I'm generating tables of data and whatnot. It's a quick way to generate lots and lots of data that I can throw at something. But I'm going to stop with the maybe silly answer, but I think true. How do you test code is still something that's very appropriate.
Yeah, and just to quickly add on that, how do you test code that's generated by a code generator like Lex and Yak or the modern equivalents? How do you test code that's generated by a model-driven environment? Same exact issue. Really, nothing changes. In fact, that's the beauty of this. We should have the test processes in place. We should have the DevOps processes in place. We should be automating this stuff as much as possible. So to the extent that generative AI is used, it should go through exactly the same scrutiny, if not more so. But it's certainly what you've got already. Keep doing it. This is great.
Oh, that's awesome. How about you, Ipek?
I completely agree with James and Doug there, but maybe there's hidden in that question is another underlying effect, which is, are there going to be different classes of errors that we're not maybe anticipating with generative AI, and do we have the tools to test for those? So I think that's where maybe there's a difficulty or unknown that we don't anticipate it to be too different, because it's still code is the data that is going in terms of the training as corpus. The outcome is also data. We already have tools in terms of catching whether it compiles, whether it is correct and whatnot. But I think that's maybe a slightly open area for investigation in terms of, are there classes of errors that we need to investigate, and do we have the tools to pick those classes of errors? Or how do we educate the developers, humans, to be able to catch those so they don't even enter the software systems throughout, and it becomes harder and harder to catch downstream?
There may be another piece here too, which is in that question, which is who will guard the guards? If we have AI-generated code and AI-generated test cases, do we really have any faith that these things work? And so that's where, once again, I think we would all agree humans matter. Getting some wetware from our brains involved in this process is absolutely crucial.
Yeah.
If I get just one more thought. So this is an idea I've been playing around with a little bit, and I've shared this with a number of you on this panel, is I think it's entirely possible we see a resurgence of skills that we maybe actually like code review, right? Watts Humphreys taught code review and personalized code checklists that were oriented towards the coding errors you tended to make. To Ipek's point, maybe there's particular forms of errors that generative AI is more apt to make. But I think some studies that we've seen, for example, in code translation and code generation, is there's a shift in the cognitive load from writing the code to debugging the code and reviewing the code. And so I think the importance of code reviews probably goes up, at least in the short term, while we understand the space a little better.
Yeah, please go ahead, Ipek.
I think clearly this is a topic which we're all excited about. It's testability, we always argue, is in fact a property of the system, not just the code you write. And I think there's aspects of that that is really critically important. Whether Gen AI makes it harder or easier is really going back to some of the fundamentals. We do have some of these techniques. We have established some of these concepts. We need to make sure that we do not drop them and bring some of the new data that is coming back into the system. But there's is generative AI code and systems less or more testable? That's probably an aspect of the conversation that needs to be also thought about.
I think it's also
I think these are great comments. Roy from our audience said testing, sure, but how you test depends on how the code was written in the first place. AI's code might look quite foreign, thereby harder to test. So just some additional thoughts and additional comments. One of the questions that we had received beforehand, also along these lines, is to apply generative AI tools in software engineering practice, I would like to know more how we can address security, privacy, and explainability of the tools. And so this is Borachat that had sent in this question before. Any thoughts here on security, privacy, and explainability?
One of the knocks against generative AI when it first came out a year or so ago was it was trained on Stack Overflow postings and GitHub repositories that had all kinds of defects and buffer overflows. So therefore, we should not be surprised if it was full of bugs and defects the same way human code is. That was certainly a concern at the beginning. I think we're getting a lot better at training these models on good code that hopefully follow best practices. But by the same means, we don't want to eat our brains and start doing things that will be risky. And I think that's another theme that keeps coming up here about skill atrophy. People used to have to do register allocation by hand because compilers didn't exist. I think it's pretty fair to say that very few people today could do register allocation by hand anywhere near as well as a tool can do. So skill atrophy is really a matter of what's replacing the skill that is being atrophied with something better. There's a great quote by Edgar Dijkstra who once said, "The purpose of abstraction is not to be vague, but to define a new level at which we can be absolutely precise." So we have to think the same way. We don't have to throw away all we've learned from 60 years of software about building layers of abstraction and building firewalls and modules that are composed and they hide things. I think that comes back to these points. We need to make sure we follow all the best practices. It's just that we may have some exoskeleton for our brains help us to be more effective when used properly.
Appreciate those thoughts. John, did you want to weigh in here?
Sure, those are great topics. So maybe just hit quickly a couple of aspects on each one. So privacy, that was discussed a little bit ago. I think for software acquisition, disclosure and privacy is really critical because acquisition typically deals with proprietary data or CUI or controlled unclassified information. So it's really important to have architectures and considerations to ensure that those regulations and those requirements are met. I also want to touch on security. That is an area of active investigation and conversation. I think there's a lot of activity on that, and it's again part of the risk-benefit trade-off that James and others have talked about. And then also talk about explainability. I think there's been community conversation about different generative AI solutions and whether or not they're open about the types of data that they use and the different types of models and transparency on how those are trained. So again, another active conversation happening in the community. One more point on this is that I think from a software acquisition standpoint, it's important for everyone to be aware that there's evolving or changing governance and regulation on this. At a top level, the White House executive order talked about the development and deployment of AI in a trustworthy and safe way. That has a role that everybody has to be aware of, maybe at a top level. And then services in particular have their own guidance, like the Department of Navy issued guidance on generative AI and large language models. And it's important for people to be aware of these evolving and new regulations and as they explore these different opportunities.
Yeah, really, really important considerations, John. Thank you. Shen, I think you had a couple of comments to make here too.
Yeah, so just to add on to what John said, I think in the commercial sector, organizational policy plays a huge role in scaling up the use of Gen AI. I think as we saw last year, there were a couple of employees from Samsung that leaked proprietary information, and almost immediately Samsung clamped down and said, no use of ChatGPT or Gen AI for our engineering staff. And I think a lot of other companies kind of followed suit in that wave in 2023. And I think, on the other side of the spectrum, you've got a lot of companies in the tech side that say, please, by all means, use generative AI in your software development efforts. And so I think having a consistent organizational policy that applies to everyone and making sure everyone understands that policy and how to interact with commercial LLM services is going to be a key moving forward.
Yeah, I really appreciate those thoughts. Ipek, earlier you had brought up the issue of trust. And one of the questions that we had received earlier from Louise is about trust. Is it trustable? His question, is it trustable to use generative AI in software development, in the software development process? And I think that is a question that many people have, is how can we trust what we're doing, or how can we trust Gen AI in as we're developing our these really complex applications.
So the biggest eye-opener for me in this conversation was when I was debating with a colleague. He said, what makes us trust developers more than the tools? So it's really important to recognize what is really, first of all, it goes back to everything that was said and what James said. What is our threshold for trust? What is our risk exposure? And what is the task at hand and why we're using, it's not just generative AI tools. There are other tools that are using other AI-based tools that are, in fact, we're seeing significant improvements. Like, for example, in autocode correct is an area where it's not generative AI tools, it's different AI tools, and they've been improving, which also gives us the data. So I think it's really the data, the empirical basis, while not really leaving things to chances, to make sure that we have whether it's the testing processes, it's the guardrails, human in the loop, things will happen. It's really how do we increase the threshold and how do we make sure that we have continuously the data that we can rely on to understand whether mistakes are introduced and whether we can locate them. And maybe for some mundane things, this is okay to trust because we can we have established enough of a corpus to know that the risks introduced are not necessarily that critical. So I think trust is something that will improve in time, but it also needs to be always brought back to the environment, the task, and why is it that we're using this particular tool for that issue. But it's important to recognize if we're not trusting, a particular tool, what are we trusting more and why? And can we replicate that? And how do we, maybe there's a collaborative aspect of it, not just one tool or humans. How do they together increase the trust is probably the right way to look at this problem.
That's great.
Another thing just to throw in real quick. So
Yeah.
you think about the fact that the vast majority of bugs written over the past 50, 60 years have been written by people. We have to ask the question, why do we trust our developers? And I think this is kind of what Epic's saying. So I'll go back to what James was saying before. It's really about the workflows. We need to figure out how to make workflows and processes. So we're not trusting people. We're not trusting generative AI. We're not just trusting model-driven development environment tools. We're trusting a workflow and a process with all kinds of safeguards along the way. That's really crucial.
I love that. Thank you so much. So we're getting to sort of the last half an hour, and our team thought it'd be fun to do just a couple of speed rounds. So this is where everyone's going to have a chance to weigh in. And so we've got a couple of our speed round questions. The first one, what are some of the skills needed for people using generative AI in software engineering or software acquisition? And we're going to hear from the whole team. Epec, I'd like to start with you. So we'll do Epec, Shen, John, James, and then Doug. So Epec, please.
Ironically, it's expertise and review expertise, whether it's the code or the architecture or whatever it is. And in fact, one of the studies that was published last year by Microsoft looking in Copilot, Taking Flight with Copilot is the title of the publication, and it was published in Communications of the ACM. Their reflection was, in fact, these tools will require more expertise from developers rather than less. So what does it mean to be an expert and reviewing expert, and what is the aspect of the system that you're reviewing is going to be a top skill that we'll need to develop both in our early career software engineers as well as any walk in their career path, what skill sets they have that they're experts and they can judge the outcomes.
Great, thank you. How about you, Shen?
I think a central skill that needs to be developed is prompt engineering. I mean, prompt engineering itself has almost turned into a whole field. But in terms of interacting with generative AI, in terms of text inputs, being able to iterate and refine those prompts to get quality output is going to be key moving forward. Because as some of you may notice, if you just open up ChatGPT or any of these commercial services, you just ask for it, but give it a very vague prompt or a very simple question, you're going to get garbage out. So it's very much a garbage in, garbage out kind of tool. And so being able to play around, experiment, and leverage, and reuse some of these prompt engineering patterns, many of which are in literature out there, is going to be key moving forward.
All right, so prompt engineering. All right, John, and I know, John, that's something you talk a great deal about as well.
Yes, and just to build on what Shin just said, I think for me personally, experimentation is one of the key skills, because there's so many different ways that generative AI can affect a workflow or a daily routine, whether you're in software engineering or software acquisition. So to really affect change, it's coming through with a personal sort of checklist. Here's the kinds of things that I'm trying to accomplish. What are the kinds of concerns I need to be paying attention to, like privacy of data, et cetera. And then how can I get maybe a quick start using generative AI. And I personally found, experimentation, understanding how to get me to the end state faster is very, very helpful. It's provided a lot of benefit. And I think that's where in the community, people see a lot of benefits as well. A test engineer who's writing test cases, as we've talked about, creating tests very quickly, creating test data very quickly, software acquisition. I need some really good bullet points on how to do an RFI. It doesn't have to create the whole thing. It's a quick start. So I think experimentation is what I would say.
Yeah, that's great. We've had to bring that kind of thinking even into our own team to be able to learn, with the different tools and just keep up with where the field's going. So I totally agree. James, how about you?
I have two thoughts. The first is the importance of problem decomposition, the ability for the human interacting with the generative AI to break this hard, fuzzy problem into crisper, smaller problems that generative AI is more capable of solving, and the ability to compose solutions that come from generative AI and other techniques into the solution to the problem you're really trying to solve. So that general problem solving and decomposition skill is huge. The second thing is more of a mindset that I think of as measured skepticism, right? We don't want to fall into an automation bias where, oh, wow, ChatGPT is just so compelling. This sounds like it makes complete sense. I will just go with it, right? So we always need to remind ourselves not to get sucked into how good it can be, because it really can be, and be mindful that I need to double check some of this. I need to take responsibility for the outcome, because that's not what the AI is going to do for me.
Excellent, excellent points. Doug.
So these are all great points. I'll try to say two things that are a little different. One is curiosity. Almost everybody I've found who plays around with these tools quickly learns what they're good at, what they're not good at, and how to compensate for the limitations. And I don't think I've met a single person who started using it who didn't find it incredibly useful once they spent some time being curious and trying it out. So that's number one. Try it out. It's real easy to get started. Like I said, for the price of a cup of coffee, a couple cups of coffee, you can get the plus version of ChatGPT and be much better off. Second thing, this is kind of riffing off of what James was just saying, an awareness of the Stockdale paradox. Admiral Stockdale was a prisoner of war during the Vietnam War. He was also Ross Perot's running mate in the '92 campaign. And he came up with this concept, which is put forth in the book Good to Great by Jim Cramer, that says, if you're going to survive something like being a prisoner of war, you have to both be optimistic at one level that you're going to be freed at some point, but you also have to be very realistic that things may not go your way day to day. And when I use large language models and generative AI, I'm optimistic about where we're going, but that doesn't mean it works all the time. But maintaining that optimism, to James's point, that kind of creative skepticism, measured skepticism, that's very important. But I think we also need to realize how transformational this stuff is. And we have to figure out how to work with it effectively to be productive in our careers.
That's an excellent point. Sam from our audience asked this question: will software developers be replaced by AI? And I know there's a fear of that. And I think someone else had asked a similar question, but your thoughts, all of you can chime in on this, but your thoughts.
Real quick, there's a great quote. I'm sure people have heard this. AI will not take your job, but somebody who knows how to use AI better than you will may take your job. That's how I would look at the answer to that question.
Yes, yes, great response.
So I'd share no, but I'm hopeful that it's going to take some of the drudgery away and let me do the harder, more interesting bits and focus my time there. And that's going to be more satisfying for me.
Yeah, so maybe taking some of the day-to-day things away, but leaving the creative problem solving and thinking to the humans. Yeah.
And maybe I'll add to it, if you continue to resist change, yes, it will replace you particularly. I think it's similar to what maybe Doug has said, but there's also a lot of resistance to change when we see some of these tools working. There's this healthy skepticism, and where does the healthy skepticism sit? And when do we embrace and when we don't embrace? I think that's important. And I think if they start working, and they will start working in some tasks, then we need to start taking advantage of them so we can move to the other aspects. If we don't do that, then yes, they will replace either with a better developer or a tool.
Great comments. There's a couple of comments that we've received from the audience that I was just going to read. Cody, the paper, The Irony of Automation, 1983, concludes something similar to Dr. Ipek about the need of more engineering expertise. And then a comment from Roy: experimentation is fine, I'm in favor, but it's shocking how many computer scientists are completely ignorant about rigorous research methods, which is not required in most CS departments. So just a couple of interesting thoughts and comments there. Yes, please.
Yeah, on that comment, I think this is an incredibly important comment. And in fact, we are so great at separating the software engineers to practitioners and researchers. Those are skills that a software engineer has to have. And I think with AI-like tools entering the software developers' workforce, we need to be a little bit more of the researchers, which is a task is analyzing data, generating data, understanding what it means. That needs to be part of the developers' day-to-day, maybe curiosity. Not everybody does that, but I think that's important. Similarly, ivory tower research, if you're a researcher as such, you'll not necessarily hit the mark. You really need to touch the code and be really integrated. And I think that brings AI tools, hopefully, maybe finally bridge that gap.
Well, it's also kind of funny because anybody who's ever tried to track down a race condition in a concurrent program on a multi-core processor has in one way or another applied the scientific method if they were able to solve that problem. Because you have to divide and conquer, you have to isolate things, you have to try different experiments, see what works, see what doesn't. You build mental models in your head. I think a lot of that comes second nature to software developers. Maybe it's something we could learn and do better, but if you're a good software developer, you're very good at experimentation because that's how you solve problems. And that's what we are ultimately as problem solvers.
Excellent, excellent point. So the second question in our speed round is, as we consider this technology area, what might the future look like? And again, I'd love to hear from all of you. This time, John, if you would get things started. So we'll go with John, Shen, Doug, Ipek, and James. John, please.
I think the future is very exciting. And as was stated at the very beginning, when you mentioned the National Agenda study that was done about humans and AI working together, and when Ipek and James talked about that, I really do see a lot of that starting to happen more and more. So the future, speaking of software acquisition specifically, there are opportunities now to balance the risk and risks and challenges and opportunities for software acquisition in so many different areas. So document summarization is one of them, and identifying discrepancies either within one document or across multiple documents. Clearly, there's opportunities for regulatory sort of descriptions, and regulatory compliance is another area. And as I talked about, domains in specific areas such as safety of aircraft or ships as another area where there's going to be more and more growing data. But over time, as these tools become more available and maybe more specialized, I think we will start to see in software acquisition a lot of interest in having some specific tool sets and resources for specific services, domains, environments, and that should be really exciting. But it's also poses some really amazing new challenges, because keeping the data updated, making sure that we have trust, we have processes that enable people observation is really critical. And as organizations bring these new processes and tools into their organization, those have costs too that need to be managed and maintained over time. So I think the future is very bright, but there's going to be a series of steps that need to be occurring to get us there.
Excellent. Thanks so much, John. How about you, Shen? What does the future look like in this technology space?
So I want to piggyback off of what John said in terms of specific domain applications, because presently, a lot of the large language models we see out there are for general purpose tasking. And there have been a lot of research done on large language models applied to healthcare or finance. But for more sensitive domains like defense, there will be a need to come up with very finely tuned models to perform very specific tasks. And I think what the future might hold is potentially, instead of large language models, maybe we have small language models that are designed to do very precise tasks that have been measured and verified to achieve very specific capabilities. And I think that future is very bright, but also that future holds a lot of unknowns, right? How are we going to verify those models?
Right.
A lot of the traditional verification means are give it general purpose, high school tests, right? We're not going to do that with a language model that's going to be used in the defense industry. So it's going to be very interesting to see how these models, evolve into more specific applications.
Excellent, excellent. Great things for us to consider. How about you, Doug?
So most of our discussion today is focused on software engineering, as I think we've learned it coming up the ranks, learning to program, learning to design, learning to think about architecture, testing, other upstream activities. And I think that's great. What I want to focus on briefly here, however, is the ability to unlock opportunities for all the other fields that don't have that kind of formal background, who need to be able to use computation to be successful in their professional endeavors, be it researchers, people doing various types of work in e-commerce and other parts of the commercial sector. In those contexts, historically, when those people would come to us, software engineers, and they'd say, we want to apply computing in physics or biology or computational chemistry or English literature or whatever, we would say, fantastic, we're going to teach you how to program in Java or C# or JavaScript or whatever. The problem there was that that was too far away from the domain. Most people didn't want to learn to be Java programmers. They didn't want to learn even to be Python programmers for that matter. They wanted to solve their problems using computation. And one of the things I think that's going to happen in the future is more and more people in more and more domains will be able to apply computation to do very interesting problems through the use of natural language programming, as opposed to natural language processing, and prompt engineering and large language models and generative AI tools. So I think that's both very exciting because a lot more people will be able to participate. It's also kind of scary because a lot of those people won't have the background that we do as software engineers to think holistically about what needs to be done to make their systems work and live over time correctly and safely and securely. But I think it's an opportunity to get a lot more people involved, and that's quite exciting.
Very exciting. Thank you so much. How about you, Ipek? What does the future look like in this space?
So I will start with what kind of a future, or what is the new future we're looking for, 3 to 5 years, 5 to 10 years. And I think for the first couple of years, we're looking at a little bit of a confusion and not knowing where to apply, maybe not really fit for you. So we'll have to really be very careful as we go through that stage, and that we should not take it for granted, because that future is like in next, and that's probably going to define what will come afterwards. However, I also would like to bring it back to the fundamental question. Why are we so excited about these tools? Because they give an opportunity in terms of the better systems that are more fit for their purpose, that are developed with better resources, and that we can trust. And ideally, that's going to happen. What's going to happen? We'll see less technical debt, less critical errors, because we'll be able to learn from it and catch them, and really then be able to envision some of these kinds of classes of software that are not real, like autonomous vehicles and whatnot. So I think that's probably more longer term in terms of the future, but I think these classes of tools will get us maybe there a little closer. But I want to focus on the near term future, which is like the next couple, and we should really, really be braced and work through those steps carefully so that we can really look into the future that is the more exciting, that we're all here for and doing work in this area.
Yeah, I love it, because all of you have said what an exciting future we're poised for. James, you've got the cleanup spot on this one.
Oh,
How are you thinking about the future in this space?
so I'm thinking about what I hope to see.
Okay.
I think I'll start with right now. I think we are in this crazy, exciting, creative, experimental phase with generative AI. We're trying lots of things, and they don't all make sense. That's okay. We're learning what we can do, what we can't do. We're trying to learn where the good fits are. What I'm hoping to see is a quick shift. Maybe it's EPEX the next 1 or 2 year time frame, where we have a much better handle on responsible use of generative AI. Where are the places where it's not just fun to use it or cool to use it, but coming back to the fundamentals of software engineering, how does it make us better, faster, cheaper? How does it really affect the bottom line, make our businesses better, make our organizations better, accomplish mission more effectively? Because at the end of the day, we're really trying to achieve something through software. Software is not really the goal. But I think there's huge potential to help us, and we really need to hone in on those responsible uses and help everyone come up to speed on how to do that effectively. And of course, we'll continue to innovate, but concentrating some attention in the next couple of years on the really compelling use cases, I think that's what I'm looking forward to.
I love that. And I know some of the work that we're doing at the SCI is really starting to look at a lot of that in a lot more detail. So I think that's great. Another aspect of what the future might look like. These are actually several questions I've received on this topic. Questions from someone named Greg, someone named Elvia, several people. How can we prepare software engineering undergraduate and graduate students for the future of software engineering as we look at Gen AI and other things, other technology areas?
Yeah, I'll take a quick shot. I'm sure lots of people will chime in. So this is what we think about a lot in my role as a professor, trying to help formulate a curriculum for our department. I do a lot of software engineering work. This is the big question: what should be in that curricula if we're going to be thinking about that? I think right now, to James's point, it's still kind of the beginning phases. We're kicking the tires. We're seeing what works and what doesn't. What I would use as a guideline to help make sense is think about everything you do when you teach your courses. When I teach my courses now, my first inclination when I come up against something that's mundane and boring and repetitive is, how can I automate this using generative AI. And it's opened up a whole new way of doing teaching. It's done a whole new way of me learning. When I want to learn some new topic, I had to learn how databases worked in a microservice-like approach with asynchrony recently. I was able to use ChatGPT as my trusted mentor. It got me where I needed to go without having to spend years getting a master's degree and reading tons of documents to get to the point where I could become proficient enough to teach my students. From there, I learned more, they learned more. So I think right now it's about just getting in and trying it out and seeing. The formalization will come as we get a better sense of what is there and as the tools start to codify as well. Right now, everybody's all over the place.
Yeah, but I think you've mentioned a really good point, which is all of us learning. So we've got to all be proficient. And so as you think about how we update our skill sets, it's a lot of experimentation, a lot of trying, and then of course, and how we teach our students. So I think these are great comments. Others, please.
I'll jump in.
Yes, please.
I think the AI tools are hopefully making us recognize that there are a class of skills that we fail to teach in the undergrad and grad level, which is, can I fix somebody else's bug? Can I find somebody else's bug? Can I make sure a change that I'm making is consistent across the system? What does large mean and how do we evolve these kinds of systems? And this is more of an expertise level skills, and it's always has been assumed that individuals take these up when they join the workforce. I think waiting that late will not be as effective with these tools out there, because developers and software engineers will need to deal with these more day out. And I think bringing those skills more into the undergrad and grad levels will be important in terms of evolving the code, finding different bugs, finding other people's bugs and correcting them. And this goes with or without AI tools. And I think some schools are being more proactive in terms of, rather than fighting the tools, incorporating the tools. And there are kinds of things that will change in terms of what students are able to learn with a tool versus without a tool, and how those skills change. And I think that's going to be something that we'll have to see as these experiments go on in the education space.
Excellent. Any other thoughts here? Okay, well, I've got a few other questions that have come in from our audience. So we've just got really about 7-8 minutes left. Let me try to see if we can tackle some of these. So from our audience, what about code maintenance and updates to requirements? How does generative AI fit in, or would we depend on human developers?
So I'll say I think we depend on human developers to learn how to use a variety of tools. Some are generative AI tools, some are not. And in terms of maintenance, one of the things I find very useful with generative AI tools, even in their infancy, is the ability to do rapid refactoring. Oftentimes I'll get code. A lot of times my students will write code that's not very well structured. And with not much effort, I can run it through ChatGPT and ask it to refactor the code, to separate concerns, to figure out what's the platform dependent pieces, what are the platform independent pieces, apply the solid principles, if you're familiar with object-oriented design principles. And it's actually very, very good at that because it was trained on a large amount of software that knows what those principles are. So maintenance is a great example of how you can use this stuff. And of course, since you should be writing your test-driven development unit tests, as you do the refactoring, you can continually check to make sure that the changes you've made to make the code more modular and reusable and portable or whatever don't break the requirements as embodied in the test cases.
Great, thank you. Shen, I thought you might want to weigh in here.
Yeah, so in the area of maintenance, one of the issues is, if you have outdated documentation, what are you going to do? And I think one of the strong points of Gen AI is being able to come up with documentation, which still needs to be reviewed by a human, but basically explaining the code when you might not have documentation. And I think that's a strong area where Gen AI can really expedite maintenance efforts, especially when we're talking about legacy code bases.
So if I can add just a little bit to that, I think Doug and Shen have both touched on an important topic. When you're maintaining code, often it's not code that you wrote in the first place. So orienting yourself to that is really helpful. And even if you do have documentation, it may be out of date. That's imperfect information. But again, mindful kind of skepticism, the generative AI summary may be incomplete as well. So there is that responsibility still on the developer, not just to trust this summary has everything, because important facts or connections could be left out. So again, pairing that with other techniques. And one thing that I think is really important and maybe is a good opportunity for Gen AI is a lot of code that you're maintaining doesn't have good unit tests to start with. And as you go and you start making those changes, any technology that can help us get a better handle on knowing whether our changes will be successful are a big advantage. And that is an opportunity that we can look at with Gen AI.
Excellent. Thank you so much. Here is another interesting question that we've received from our audience. We haven't really talked a lot about ethics and legal issues, but Vicky's asking, would a certain level of legal and ethical maturity with Gen AI be critical for broader adoption by software engineers across enterprises? I think these are also some really important considerations.
So that's a big issue in a lot of companies. I forget whether it was a Shen or someone mentioned before that Samsung wouldn't let people use LLMs. That's a very common issue. There are, however, companies, and I'll put IBM forward as an example because someone from IBM told me this recently, who are actually going to indemnify the output from their versions of generative AI to make it free of patent infringements and make it free of copyright violations. So I think what we're going to see is an emerging ecosystem of people who spend the time to do rigorous vetting of what their code has been trained on, their tools have been trained on, the LLMs have been trained on, so that what is generated will be free of those issues. And there will be a certain group of people that will only use those kinds of systems. Other people will continue to do the sort of the Stack Overflow model of cut and paste what you can get your hands on. And we'll see the legal system will sort this out at some point, I'm sure.
Agree. Others on that?
Well,
go ahead, Ipa.
I think with ethics, this is hopefully an opportunity to raise the bar regardless. I think, like, for example, software reuse had all kinds of implications. Generative AI just accelerates some of these. What are some of the responsible ways to implement things? I think generative AI and AI kinds of techniques with data bring it to our face. But if you look at a lot of the code of conduct, ACM, IEEE, all these said, code of ethics for software engineers and computer scientists is in fact has been there. It's just hopefully this is an opportunity where it's more widely understood, widely adopted, and the implications of the data we use come back to it. So I think the answer is absolutely, but this is an opportunity rather than a barrier.
Excellent. I know we just have a couple minutes left, and so I'm just going to ask one last question from the audience, and it is from Somonath Mukherjee. What are open source large language models that can be used to help in software engineering? So what are you all experimenting with, and what are you all using here? Shen?
Yeah, I can start. So, we're not going to endorse any specific products, but as some of you or many of you are aware, Meta, they produce the Llama series of models, which are trained on a public corpus of, essentially terabytes of data on the internet. And from Llama, there have been a lot of derivative models based off of that are fine-tuned for specific applications. And again, not to endorse, but if you go on, huggingface.com, you can find other models of similar capabilities. And there's a lot out there, and I encourage you all to play with them if you have the GPU resources available, and definitely learn up on them because it's a rapidly changing field out there.
Great. Doug, would you like to comment?
Well, I was going to give it to John because he's been doing some work with that.
Yeah, great. Go ahead, John.
I was going to say, just building on what Shen said, I think one of the most amazing things in this area is just how rapidly things are changing, right? So as Shen mentioned, there's several resources and there are tool sets that allow you to download different models and compare very easily the results of different models. And I think one of the things, again, not to endorse any one model, but I think one of the things that's, there's a couple of trends that are very encouraging. One is that things are getting progressively better and better at various things. I think there's more progress on however you want to measure it, whether it's looking at code or looking at documentation. There's certainly advancements that are happening. And then the other thing that's happening is model size. So the models are becoming a little bit more effective at the smaller sizes. And in small experiments that I've done, I've seen some of this happening too. So I think, not to endorse any one model, but I think the thing to do is to, if anyone's interested in really trying to apply it in their organization, is to plan for and accept that there's going to be a lot of change over the next period of time, and embrace that. You understand what are the test sets that we need to use. So, for example, in our cases, we're looking at having test cases, test sets that we can look at any one large language model, open source or not, and try to understand what its strengths and weaknesses are to try and get some sense of overall performance.
All right. Well, with that, this concludes today's webinar. I hope you can see how passionate we are about this topic and about the whole future of software engineering. I would like to thank our expert panel. My gosh, I have the fabulous opportunity of working with them, every day. They're just awesome. And I want to thank all of you for your enthusiastic participation and great questions. Our next webcast will be January 31, and the topic will be Ask Us Anything, Supply Chain Risk Management. Registration information is available on our website now and will be emailed out as well. If you have any questions or comments from today's event, please send your questions and comments to info@sci.cmu.edu. Thank you all very, very much.